Hello students, in this video we are going to discuss about the parallel combination of electric cells. Here in this diagram I have taken the two cells of EMF E1 and E2 and internal resistances R1 and R2 as shown. The two positive terminals of the cells are connected to point A and the two negative terminals of the cells are connected to point B. Now these two cells are said to be in parallel combination. Assume that the current from the positive terminal of the cell 1 is I1, the current from positive terminal of cell 2 is I2. These two are combining together at point A and we have I is equal to I1 plus I2 as per the Kirchhoff's first rule. And these two cells are connected in parallel. So the potential difference between the two terminals of the two cells are equal. So first of all, the potential difference between the two terminals of cell 1 is equal to E1 minus I1 R1. So from this we can write I1 is equal to E1 minus V divided by R1. Take it is equation number 2. Similarly, the potential difference between the two terminals of cell 2 we can write E2 minus I2 R2. From this I2 is equal to E2 minus V divided by R2. From equation number 1, 2 and 3 we can write from equation number 1, 2 and 3 we can write I is equal to I1 value is nothing but E1 minus V by R1 plus I2 is E2 minus V by R2. I can write this one is E1 by R1 plus E2 by R2 minus of V into 1 by R1 plus 1 by R2. I can write the same expression V into 1 by R1 plus 1 by R2 is equal to E1 by R1 plus E2 by R2 minus of I. So this is V into R1 plus R2 divided by R1 R2 is equal to E1 R2 plus E2 R1 divided by R1 R2 minus of I. If you send R1 plus R2 by R1 R2 towards right, we will get V is equal to E1 R2 plus E2 R1 divided by R1 plus R2 minus of I into R1 R2 divided by R1 plus R2. It is in the form of V is equal to E equivalent minus I into R equivalent. By comparing these expressions, I am naming it equation number 4 and 5. By comparing equation number 4 and 5, we will get E equivalent is equal to E1 R2 plus E2 R1 divided by R1 plus R2, that is also can be written as E equivalent divided by R equivalent is equal to E1 by R1 plus E2 by R2. Similarly, R equivalent is equal to R1 R2 by R1 plus R2. From this also we can write 1 by R equivalent is equal to 1 by R1 plus 1 by R2. This is the final expression for the cells connected in parallel combination. Now here the same thing I am writing. If there are n number of cells, if there are n number of cells connected like this, externally with external resistance R, having the EMFs E and internal resistances R, then the current, net current is suppose say I, then total current I is equal to E net divided by total resistance.